of reactions occurred such Okay, so a series of reactions in the cell, because that's what happens, have occurred such that the pH of this cell has shifted slightly alkaline of target. Okay, so we've got this target range, so we're alkaline, which means our pH is acidic or basic? Basic. Okay, so this means which would be a better buffer action. So here are your choices. A, I'll say to bring pH back in target range. So H2PO4 minus releases H plus and becomes H2O4 2 minus, or B, HPO4 2 minus absorbs and becomes So in order to answer this question, we need to know a couple of things about pH. And I know that everybody already knows these, but let's just put them on the board as review.
So if we're too basic and we need to become acidic, we need to release hydrogens, right?
That's right.
So it's A?
Yes, it's A. So when you're in basic conditions, and I know that most people learn this as you have more hydroxyl groups and fewer H+. Does that sound familiar, like the OH minus and the H+?
Mm-hmm.
There are a lot of other things that cause basic or minus, so we're going to say not enough H+ relative to basic molecules. And acidic concentrations and there are all these different definitions of an acid. There's a Lewis acid, and there's all these other things where you're talking about electron donors and electron acceptors and proton donors and proton. For us, if you're under basic conditions, you don't have enough H+, and you have too many basic molecules. If you're in acidic conditions, you have too much H+, and not enough basic molecules. Okay, and our range, our physiologic range in our blood, it can change a little depending on which cells you're in, is 7.3 to 7.4. If we go, and some people even say 7.35 to 7.45. If you end up with a patient that's already down to like 7.2, you've got severe metabolic acidosis. You're going to talk about that in 415, probably B. This is a big problem. So, but for us right now, so to answer our question, so if we're in basic conditions, we don't have enough H+. We need, relative to the basic molecules. So to get our, so let's say, so if our range is 7.35 to 7.45, our basic is now, we're now at 7.48. We need to go back that way. We need to add hydrogen so that we can go back to 7.35 to 7.45. To add hydrogen, we need to release hydrogen from H2PO4 minus, and then that molecule becomes HPO4 2 minus. We do not, just as a side note, want to release this second hydrogen from here, because all of a sudden if we do that, then we have a PO4 3 minus running around, and that's going to change our pH in a different way. Okay, when you have a buffer, you have a buffer state because this is functioning as a weak acid. I'm trying not to do it anymore. Okay. As long as we understand this, we're good. Does everybody understand this? Are there questions on this as far as releasing hydrogen or absorbing hydrogen? Okay, if we were going the opposite direction, if I said we were too acidic, which means we're slightly acidic, of target, which means the pH is too acidic, we would have done B. Because they would have been able to take some of these extra hydrogens out of the solution, which would have brought the pH, like we were at 7.33, we would have brought the pH that way. Taking some of the hydrogens out of the solution shifts things basic. Putting hydrogens in the solution shifts things acidic. Okay, so adding and just because you're going to need this in 415A, so you're not going to memorize this, I'm just putting this here now. So this is really interesting. So H2CO3 will go to CO2 gas, which is what makes it such a good buffer. I'm going to put this in a box and say for later, but you're going to need that for later. Okay? So if you're running this as a buffer, so they'll test your carbon dioxide levels in your blood. Okay, because you can see, so H, right, 2O, you take an O out, and then you get carbon. So if you've got too much carbon dioxide in your blood, you're headed in an acidic direction. Anyways, so you'll need that for later. Okay.